In a bustling showroom in Shanghai, a sleek new electric SUV emblazoned with "Build Your Dreams" across the back draws a curious crowd. Half a world away in California, Tesla's Model Y glides silently off the production line, destined for an eager driver. These scenes capture a new electric rivalry unfolding on the global stage: China's EV giant BYD versus America's trailblazer Tesla. What began as an underdog story, with Tesla's Elon Musk once literally laughing at the mere mention of BYD as a competitor, has evolved into a high-stakes contest for the future of electric transportation. Now BYD, short for Build Your Dreams, is emerging as Tesla's fiercest challenger, leveraging its mastery of battery technology, massive scale of manufacturing, and home field advantage in China's booming EV market. This journalistic deep dive will explore how BYD is taking on Tesla, examining the technical and strategic dimensions of their battle. We'll tour their factories to compare manufacturing philosophies, pop open battery packs to see whose technology has the edge, and delve into how government policies and market dynamics in China and the US have fueled BYD's rise and posed challenges for Tesla. Along the way, we'll meet the personalities and cultural mindsets behind each company, from Elon Musk's Silicon Valley swagger to BYD founder Wang Chuanfu's quiet engineer's ethos. Grab a front-row seat as we explore this electric showdown between an American icon and a Chinese powerhouse. A clash likened by some to the tech world's version of Rocky Balboa versus Apollo Creed. Who will dominate the global EV arena? Let's dive in to find out. From underdog to contender, BYD's rise and Tesla's response. In 2011, when asked about potential rivals in the electric car space, Elon Musk smirked and cracked a grin at the mention of BYD. "Have you seen their car?" he quipped, dismissing the Chinese upstart with a laugh. Back then, Tesla was the scrappy Silicon Valley startup making sporty roadsters for early adopters, and BYD was a little-known Chinese battery company that had branched into making utilitarian plug-in cars. Few could imagine that a decade later, BYD would be sprinting forward to challenge Tesla's EV crown. Yet here we are. BYD has transformed from underdog to contender, and even Musk has changed his tone. "Their cars are highly competitive these days," he admitted in 2023, acknowledging that a lot has changed since that early scoff. BYD's journey is a classic rags-to-riches tale, albeit with lithium and circuit boards instead of rags. The company was founded in 1995 by Wang Chuanfu, a chemist-turned-entrepreneur, in the boomtown of Shenzhen. Starting as a rechargeable battery maker for cell phones, BYD leveraged China's low labor costs and relentless work ethic to master battery production. By the early 2000s, Wang had bigger dreams. BYD acquired a struggling state-owned automaker in 2003 and dove into the car business. The gamble was bold. Imagine a battery company deciding to build entire cars, but it foreshadowed BYD's core strategy of vertical integration. More on that soon. By 2008, BYD launched its first plug-in hybrid and caught the attention of investors like Warren Buffett, who bought a 10% stake that year, impressed by Wang's vision. Charlie Munger, Buffett's right-hand man, went so far as to call Wang, a combination of Thomas Edison and Jack Welch, something like Edison in solving technical problems, and something like Welch in getting done what he needs to do. "I have never seen anything like it," Munger raved. High praise from a Western business legend, signaling that BYD was a company to watch. Meanwhile, Tesla was blazing its own trail in the West. Founded in 2003, just as BYD was tiptoeing into autos, Tesla spent its first years proving that electric cars could be sexy and fast, culminating in the 2012 Model S, which shocked the industry by winning accolades and outclassing many gasoline peers. Elon Musk's cult of personality and Tesla's Silicon Valley tech vibe stood in stark contrast to BYD's relatively low-profile presence. For much of the 2010s, Tesla had little to fear from BYD outside China. BYD's early cars like the F3 sedan or E6 EV were functional but hardly world-class, and mostly unknown in North America and Europe. But BYD was quietly learning, improving, and scaling up like crazy, thanks in part to a massive domestic market and strong support at home. By the late 2010s, BYD had become China's top-selling new energy vehicle maker, China's term for EVs and plug-in hybrids, though Tesla still grabbed more global headlines. Then the 2020s arrived, and the story's tempo accelerated. BYD made a pivotal move in 2022. It announced it would stop making gasoline-only cars entirely, focusing exclusively on EVs and hybrids. This was like a declaration of war in the EV space. The company was all in on electrification. At the same time, Tesla opened its Shanghai Gigafactory in 2019 and began pumping out Model 3s and Model Ys for the Chinese market, tapping into China's supply chain and talent. The stage was set for a head-to-head competition, especially in China, the world's largest and most EV-savvy auto market. And compete they have. BYD's latest models, with names like the Han sedan, named after a Chinese dynasty, and the Ethos 3 SUV, inspired by atoms, sold globally, are light years ahead of its old offerings. Tesla, for its part, has slashed prices and iterated on its cars. Witness the new Highland Model 3 refresh to defend its turf. The result is that by mid-decade, Tesla and BYD are trading places on sales charts, and sometimes BYD even pulls ahead. In 2022, BYD sold over 1.85 million electrified cars, including hybrids globally, nearly double its 2021 volume, an astounding leap. Of those, about 946,000 were pure battery EVs, not far behind Tesla's 1.3 million EVs that year. By 2023, BYD had firmly overtaken Tesla in total new energy vehicle sales, thanks to its mix of hybrids and EVs, and even in pure EVs it was closing the gap. Musk himself conceded that Chinese automakers are Tesla's most likely second-place competitors, explicitly praising BYD and others for working the hardest and the smartest. The clash isn't just about sales numbers. It's a multi-front battle involving manufacturing might, technological innovation, savvy pricing, and the backing of governments. In the sections ahead, we break down this rivalry into its core components: manufacturing, battery technology, government policies, market share and market dynamics, pricing strategy, and cultural differences. Through each lens, we'll see how BYD and Tesla stack up, with detailed comparisons and insights into their strategies. It's a classic East versus West corporate duel, but also a personal one. BYD's Wang Chuanfu is a low-key chemist who rarely courts the media, while Tesla's Elon Musk is, well, Elon Musk, a brash, meme-tweeting celebrity CEO who is as much a part of Tesla's brand as its cars. The cultural contrast couldn't be sharper, and it adds spice to the competition. Before we delve into the technical nitty-gritty, one thing is clear: the global EV race is no longer a one-man show. Tesla's years of having the spotlight largely to itself are over. BYD has arrived on the world stage, and it's not content to play second fiddle. As an American observer, it's a bit like watching a new team challenge the long-standing Super Bowl champs. There's excitement, a bit of anxiety, and the realization that competition might ultimately make the whole game more interesting. Now let's dive into the details of how BYD is taking on Tesla, starting with where these cars are born, the factory floor. A tale of two factories, manufacturing showdown. One of the biggest factors in BYD's ascent has been its manufacturing strategy, the nuts and bolts, literally, in some cases, of how it builds cars and what it chooses to build in-house. To understand how BYD can churn out so many vehicles so quickly, we need to peek inside its factories and compare them to Tesla's approach. It turns out, BYD and Tesla have almost opposite philosophies on manufacturing, each with its own advantages. Vertical integration versus specialization. BYD is the ultimate vertical integrator. In a very Henry Ford kind of way, BYD tries to make almost every component of its EVs on its own. It started with batteries but didn't stop there. BYD makes its own electric motors, power electronics, and even the microchips that go into its cars. Through its subsidiary BYD Semiconductor, it produces automotive-grade chips, like the insulated gate bipolar transistors that control motor power. BYD has even invested in lithium mining and owns fleets of cargo ships to control logistics. This level of integration harks back to the early 20th century when industrial giants sought to own their supply chains end-to-end. Why does this matter? Because in modern times, most automakers outsource many components and focus on assembly. Tesla, while more integrated than traditional car companies, still relies on partners for key bits. For example, It buys battery cells from Panasonic, LG, and CATL for many models, and uses chips from suppliers. BYD's approach meant that during crises like the global chip shortage, it could keep rolling. Its in-house chips acted as a life raft, while other automakers had to halt production due to lack of semiconductors. As one industry analysis noted, BYD's control of microchip production proved an important advantage when supply chains were choked. Tesla, by contrast, has pushed the envelope in manufacturing process innovation. Musk famously refers to the factory as the machine that builds the machine. Tesla's focus has been on automation and radical new techniques to simplify car production. A prime example is Tesla's use of giant casting machines, the size of a small house, to die-cast large sections of a car's body in one piece, something BYD and others are only starting to explore. The Model Y's rear underbody, for instance, is made from a single massive cast aluminum piece, eliminating dozens of parts and welding steps. Tesla's gigafactories, from Fremont to Shanghai to Berlin and Texas, are shiny showcases of advanced manufacturing, with robots dancing in synchronized choreography and custom assembly lines fine-tuned for EVs. When it comes to production speed, Tesla's gigafactory Shanghai is a benchmark. It began producing cars just about a year after construction started, an astonishing pace in the auto industry. BYD's factories, while less publicized, have also ramped up swiftly. In fact, BYD recently boasted that its production lines can match Tesla's in output. By 2024, BYD revealed that one of its newest plants achieved production speeds comparable to Tesla's gigafactory in Shanghai. Both companies understand that to win the EV race, you not only need a good product, you need to build it fast and at scale. Labor versus automation. There's a telling difference if you walk through a BYD factory versus a Tesla one. At Tesla's Fremont or Berlin lines, you'll see a high degree of automation, robots welding, painting, and moving components. Tesla tries to automate what it can, sometimes to a fault. Musk admitted that in the Model 3's 2018 production hell, they had excessive automation and had to dial it back. BYD, operating in China with its vast workforce, historically relied more on human labor in production. An observer once described BYD's factories as having a massive army of factory workers taking on tasks that competitors might assign to machines. Exploiting China's lower labor costs, BYD could afford to be more labor-intensive, which ironically gave it flexibility. Need to rework a design or add a new variant. It's easier to train or redeploy workers than to reprogram and retool a fleet of robots. This neo-Fordist approach, lots of workers, vertical integration, and continuous iteration, allowed BYD to drive down costs while still innovating rapidly. It's a bit like the tortoise and the hare. Tesla's automation, the hare can sprint when everything runs perfectly, but BYD's pragmatic use of labor, the tortoise chugs along steadily even when unexpected hurdles pop up. As a result, BYD has been extraordinarily adaptable in an ever-changing tech landscape. A striking example of BYD's manufacturing prowess came in 2022 when it aggressively ramped up output to meet surging demand. That year, BYD not only outsold Tesla in total EV plus PHEV units, it did so by scaling production in multiple Chinese plants and even repurposing some of its facilities to EVs. BYD's Xi'an factory, one of its largest, was reportedly producing 4,000-plus vehicles per day by late 2022. The company ended up making nearly 1.9 million vehicles that year, a gargantuan leap from its previous years. For context, that's almost triple BYD's 2021 output. This ability to hyperscale owes a lot to BYD's tight control over its supply chain and workforce. They don't have to wait on as many suppliers or navigate international logistics for key parts. Most of it is under BYD's roof or umbrella. Tesla isn't a slouch either. It crossed the 1 million vehicle mark in 2022 and reached 1.37 million in 2023, and it's building new factories. A second one in China focused on battery storage products, one upcoming in Mexico, etc. Tesla's strategy has been to localize production on each continent to reduce shipping and tariffs, e.g., Shanghai for Asia, Berlin for Europe, Texas, California for North America. BYD, for now, has most of its production in China, but it's rapidly expanding overseas capacity too. One area where Tesla and BYD's manufacturing approaches intersect is battery pack assembly. Both realize that making battery packs more efficiently is key to cost and performance. Tesla pioneered the idea of a structural battery pack in its latest designs, essentially turning the pack into a part of the car's chassis to save weight and space. The new Tesla 4680 battery packs in Model Y act as the floor structure. BYD's innovation, the Blade battery, which we'll explore in detail soon, also changed how batteries are assembled in the car. BYD uses a design called CTB, cell-to-body, where the Blade battery pack is integrated such that it adds rigidity to the vehicle's structure. In manufacturing terms, both are eliminating redundant materials and steps by unifying the car body with the battery. This is cutting-edge stuff, and it shows that despite different philosophies, the two companies often innovate toward similar goals. It's fascinating to note that these divergent strategies, BYD's deep integration and labor-heavy production versus Tesla's automation and bold re-engineering, have both been successful. In fact, each is now learning a bit from the other. Tesla has started to diversify its supply chain. For example, it's now open to buying batteries from BYD. Indeed, Tesla's Berlin factory is using some BYD-made battery cells in its Model Y standard range. And BYD is automating more as it grows, and building factories abroad in places like Thailand and Brazil, where it can't simply throw thousands of Chinese workers at the problem. The two approaches are likely to converge somewhat as both companies mature. To sum up the manufacturing battle, here are a few key contrasts. Supply chain control. BYD controls from raw materials to chips to final assembly extreme vertical integration, whereas Tesla focuses on core components and outsources others moderate vertical integration. Automation. Tesla uses high automation and novel manufacturing tech, gigacasting, robots, etc. BYD historically used more manual assembly and incremental improvements. Scaling strategy. BYD leverages China's scale and labor to ramp up quickly, e.g. adding shifts of workers. Tesla leverages multi-continent factories and streamlined designs to scale. Flexibility. BYD's integrated approach insulates it from supplier hiccups and allows quick pivots. It even weathered the chip shortage by making its own chips, while Tesla's nimbleness comes from software-centric design and over-the-air update ability, even in manufacturing equipment. It's almost as if Tesla is a tech company that makes cars, and BYD is a manufacturing company that harnesses tech. Both roads can lead to success. And when we look at sheer output, in 2024, BYD actually outproduced Tesla in certain quarters, signaling that its manufacturing engine is now roaring as loud as Tesla's, if not louder. Next, we'll dive into the heart of these electric vehicles, the batteries where BYD and Tesla have taken very different bets that are reshaping the industry. Battery technology. The heart of the EV battle. If electric cars are the future, then batteries are the beating heart of that future. It's no surprise that much of the Tesla versus BYD rivalry boils down to their battery technology and expertise. BYD's origins as a battery company give it a home court advantage here, but Tesla has made bold moves with its own battery designs and partnerships. Let's unpack how their battery tech stacks up and why it matters for cost and performance. LFP versus NCA, NCM, different chemistries for different strategies. A fundamental difference between BYD and Tesla is the type of battery chemistry they emphasize. BYD has been a champion of LFP, lithium iron phosphate batteries. Its signature Blade battery is an LFP chemistry pack engineered into a unique long, thin blade cell format. Tesla, on the other hand, made its name using NCA nickel-cobalt-aluminum chemistry in its early vehicles. For high energy density and later, also NCM nickel-cobalt-manganese from suppliers like LG. These chemistries have higher energy density, meaning more kWh in the same weight, but are more expensive and can be more volatile. BYD's choice to go LFP was strategic. LFP batteries are cheaper, no costly nickel or cobalt, safer, much lower risk of fire, and have long cycle life, though they typically store less energy per kilogram. For years, LFP was seen as inferior for long-range cars due to lower energy density, but BYD's Blade battery changed the game by mitigating that disadvantage. How? BYD innovated in battery pack design. The blade cells are thin, rectangular slabs that can be tightly packed without wasted space, achieving a very high volume utilization. By structuring the pack to eliminate modules, cells are directly integrated into the pack structure. BYD can fit more cells into the car, offsetting LFP's lower density. The result, BYD's EVs achieved ranges comparable to nickel-based battery cars, but with the cost and safety benefits of LFP. In a dramatic safety test, BYD drove nails into its blade battery to simulate an internal short, a test that often causes conventional lithium batteries to burst into flames. BYD's LFP blade did not catch fire or even smoke. Its temperature remained around 30–60 degrees C, whereas a comparable NCM battery cell went into a thermal runaway, i.e., a fiery mess. This showed the world that the blade battery truly lives up to its ultra-safe billing. Tesla initially shunned LFP for its premium models, chasing longer range with nickel-based cells. However, as global battery supply tightened and LFP improved, Tesla pivoted. By 2021, Tesla started offering LFP batteries in its standard range Model 3 and Model Y, sourcing LFP cells from China's CATL. This was a nod to BYD's philosophy. For mass-market vehicles, LFP's cost per kilowatt-hour being lower is a huge advantage. Now, roughly half of Tesla's new cars use LFP batteries for standard range versions, while performance versions still use high-nickel chemistries. So in a way, BYD influenced Tesla to adopt its battery strategy for the lower end of the lineup. What about Tesla's own battery tech development? Enter the 4680 cell, a new cell format 46 mm diameter, 80 mm height cylindrical that Tesla unveiled in 2020 as the centerpiece of its future battery packs. The 4680 is not just larger than Tesla's older 2170 cells. It's designed to be made with a new assembly process, including a dry electrode coating technique, and intended to be used structurally in the vehicle. Tesla's goal with 4680 was to improve energy density, reduce cost per kWh by simplifying manufacturing, and increase the throughput of battery lines, fewer, bigger cells to handle. After some delays, Tesla started producing 4680 batteries at its pilot plant in Fremont and later at Giga Texas. However, the ramp has been slower than hoped, making a new battery at scale is hard, even for Tesla. By 2023, the 4680 was in some Model Y units, but most Teslas still use the proven 2170 or CATL's prismatic LFP. A recent study by engineers at RWTH Aachen University in Germany did an in-depth teardown comparison of Tesla's 4680 cell versus BYD's blade LFP cell. The findings are illuminating. Tesla prioritizes high energy density and performance, while BYD focuses on volume efficiency and cost-effective materials. Notably, BYD's design allows for superior thermal management, said Jonas Gorsch, the study's lead author. In plain English, the Tesla 4680 is optimized to pack as much energy as possible and deliver strong performance, important for those ludicrous mode launches, whereas BYD's blade is optimized to be cheap, safe, and space-efficient in the pack, important for making an affordable EV with decent range. Interestingly, the study found no silicon in the anodes of either battery, a surprise, since adding silicon to battery anodes is a common research trend to boost capacity. It shows that both companies are quite conservative in chemistry tweaks, sticking to tried-and-true formulas for reliability and longevity. The study also noted design differences. BYD uses a laminated electrode stack in its blade, better for cooling, since more surface area contacts coolant, while Tesla's 4680 uses a novel binder material in the electrodes and laser-welded tabs. Both Tesla and BYD use laser welding in assembly, indicating a push for precision and strong connections inside cells. Beyond cell design, how the battery is used in the car differs. Tesla's approach with the new Model Y packs is a structural battery pack. The 4680 cells are glued into a honeycomb-like pack that forms part of the car's floor pan rigidity. BYD's blade pack isn't literally the floor structure, but BYD touts that it increases space utilization by 50% through a CTP, cell-to-pack approach. BYD also uses the pack as a stressed member in some models, for example, The blade pack adds stiffness to the chassis because of its robust, honeycomb-like aluminum casing. So both are converging on the idea of making the battery pack do double duty, store energy and enhance vehicle structure. When it comes to battery production capacity, BYD is a behemoth. It not only makes packs for its own cars, it sells batteries to outside clients, including Toyota and Ford in some partnerships, and makes large energy storage batteries. In 2022, BYD's battery division installed about approximately 37 GWh worth of batteries for both EV and stationary storage. By 2025, it's likely to double or triple that. Tesla, for comparison, sources a lot of its batteries but is building up internal capacity. Its Nevada Gigafactory, with Panasonic, produces around 37 GWh per year of 2170 cells, mostly for Model 3/Y. The new 4680 lines aim for 100 GWh/year eventually, but they're not there yet. In the interim, Tesla smartly diversified to use CATL's and LG's factories as virtually Teslas, meaning Tesla doesn't mind whose name is on the cell, as long as the battery meets their specs and cost targets. BYD, being vertically integrated, prefers to use its own. One fun twist: as mentioned, Tesla has begun using BYD-made batteries in some of its cars. In Germany, the Model Y rear-wheel drive now comes with a BYD-supplied LFP blade battery pack, which reportedly improves charging speed versus the previous packs. Enthusiasts measured that the BYD-powered Model Y can sustain higher charge power for longer, likely due to that good thermal management in blade cells. It's an ironic turn of events, Tesla tacitly acknowledging BYD's battery prowess by effectively becoming a customer. On the cost front, batteries are the single most expensive component of an EV, so whichever company can reduce has an edge in pricing or margin. BYD's heavy use of LFP and its in-house production likely gives it a cost advantage per kWh. In 2023, industry analysts estimated CATL and BYD could produce LFP cells at around $80.90 per kWh at the cell level, whereas nickel-based cells were more like $110/120/kWh. Tesla doesn't break out its cost, but at Battery Day in 2020, they targeted a 50% cost reduction in the long term with the 4680 and new techniques. It's not clear they've achieved that yet. However, Tesla has an ace. Its battery management software and experience allow it to squeeze more range out of a given battery size through efficiency. For instance, Tesla's powertrain efficiency, miles per kWh, is among the best, so a Model 3 long range with a 75 kWh pack can go over 330 miles, whereas a comparably sized battery in another brand's car might yield fewer miles. BYD's vehicles historically haven't led in efficiency. They've been heavier and a bit less optimized, which is one reason BYD packs huge batteries in models like the Han to ensure long range. But BYD is catching up on software too. One cannot talk batteries without mentioning charging and infrastructure. Tesla famously built out its supercharger network, and its cars can charge at up to 250 kW for Model 3Y on V3 superchargers. BYD, operating largely in China, benefits from China's extensive DC fast charging networks, many run by third parties or state grid. BYD's cars typically charge at around 120 to 150 kW peak for its higher-end models. None of BYD's current models charge as fast as Tesla's quickest, excluding the BYD models using Tesla's battery, as in that German Model Y case. However, BYD has focused on battery longevity. Its LFP chemistry can handle many more charge cycles with less degradation. For example, BYD claimed the Blade battery can run 1.2 million km after 3,000 charge cycles with minimal capacity loss. That suggests an owner could charge and drive and charge repeatedly without killing the battery, an appealing trait for taxis or fleet vehicles. Indeed, many BYD E6 cars were used as taxis in China for that reason. In summary, the battery battle between BYD and Tesla is a clash of philosophies. BYD bets on safety, cost, and reliability with LFP chemistry and innovative pack design, Blade. It's about making EVs affordable and safe for the mass market, even if it means carrying a bit more battery weight. Tesla bets on performance and cutting-edge engineering, using high-energy cells and pushing new formats 4680 and integrating them into the vehicle structure for maximum efficiency, aimed at getting the most range and power per pound of battery. And interestingly, each is hedging into the other's territory. Tesla adopting LFP where it makes sense, BYD experimenting with longer-range chemistries. BYD has some models with NCM batteries too, especially in its premium sub-brands. The competition here has global implications, because whomever leads in battery tech can license or sell that tech to others. We may even see a day where Tesla and BYD jointly supply batteries to the world. In fact, both are investing in battery factories in various countries, Tesla in the US, BYD in China and likely Europe ASEAN, that could supply third-party automakers as well.